Okay, without further ado, we should start with the first presentation by Josef Guggemos, who seems to have a really nice mountain view from his office and will share with us data on latent profiles in computational thinking. Josef, please.
Thank you, Karin, for the introduction. Well, this is the centers in Switzerland. I'm located at the University of St. Gallen and like to talk to you about latent profiles in computational thinking. Oops. So since this is a computational thinking conference, I don't have to explain the importance of computational thinking. It is regarded as a decisive 21st century skill. In the keynote, we heard about the seminal work of Wing, and in line with Wing, we define computational thinking as solving problems, designing systems, and understanding human behavior by drawing on the concepts fundamental to computer science. So to explain our idea of computational thinking to you, computational thinking aims at representing a problem in all kind of domains. This is the first step. That in a second step, a computer or a smart machine can solve these problems. In light of this, computational thinking may be a valuable resource for problem solving in all kind of domains. Concerning the theoretical background, the framework of Brennan and Resnick is often utilized. It comprises three-dimensional computational concepts, common elements in many program languages like loops, functions, and conditionals. We've also seen all these computational concepts in the keynote. Computational practices, processes students are engaging in, like testing and debugging, reusing and remixing, but also a dimension that goes clearly beyond programming, computational perspectives, shift in perspectives, creativity, and so on. To assess these dimensions, we may rely on the computational thinking test, which is a one-dimensional performance test. It covers computational concepts and imparts also computational practices. However, it neglects the computational perspectives. And to obtain a comprehensive picture of computational thinking, it may be important to complement this computational thinking test with an instrument that more comprehensively covers computational thinking, and several authors argue that the computational thinking scales may be a viable option. It is a 5-dimensional self-assessment instrument, and it will be the basis for forming the latent profiles. So why may this be important to have such a person-centered assessment? Well, computational thinking is a multifaceted construct, so we cannot expect to have only one profile of computational thinking, but in fact, there may be computational thinkers with specific strength and weakness profiles. And knowledge about such latent profiles, students with different strength and weakness profiles may be useful for a more personalized counseling and support, because students in the same profile may benefit from similar treatments. In light of this, the research question is based on computational thinking. What computational thinking profiles can be identified? Our sample, we obtained data from 202 students from German-speaking Switzerland, from the second last grade of 3 high schools. On average, they are 17 years old. 56% of them are female, So the usual distribution at a Kantonsschule where the data stem from. They have experienced 2.9 hours of computer science instruction in the past, and 77% of the students claim to be able to program, for example, Java or Python. And students are nested in 12 classes. The data collection were carried out via Questback Unipark, an online survey, but the class teachers supervise the data collection to ensure a fair test environment. Concerning data analysis, we first have to assess the measurement model, the computational thinking scales. So for this purpose, we use confirmatory factor analysis. Then it is also important to ensure measurement invariance, so that we can really compare these groups that we form. And to form the latent profiles, we relied on the tidy LPA package in combination with M+. However, in light of our rather small sample size, we had to make restrictions, equal variances across profiles and covariances of 0, which is a very parsimonious model. We used mean scores to form the profiles, and however, Bartlett factor scores yield similar results. So this may be a viable option. Afterwards, we also evaluated the criterion validity by comparing these identified latent profiles with the computational thinking test scores. As I mentioned, this is a performance test. Here you can see the computational thinking scales. They comprise 5 dimensions: creativity, algorithmic thinking, cooperativity, critical thinking, and problem solving. Here you can find the descriptions. And I also provide a sample item for all 5 dimensions. So these are the questions from the computational thinking scale, which is also published in a paper in Computers in Human Behavior. To assess the measurement model, as I said, we relied on the confirmatory factor analysis. The problem was with the initial version of the computational thinking scale that we were not able to ensure discriminant validity. This means that items from, for example, the cooperativity dimension also significantly load on the creativity dimension, which is of course a problem. And after content review, we identified 3 items for each dimension that ensured a convergent and discriminant valid assessment of these 5 dimensions. And you can see also the fit values that are decent. However, we also faced a problem with the problem solving dimension in this latent profile forming stage, because if I may go back to the previous slide, all these problem solving items in the computational thinking scale are reversely coded. So if we include this problem solving dimension in the latent profile analysis, this yields spurious profiles. And I think this may be attributed to this reverse coding, so that the 5th dimension is in fact rather a method factor. Moreover, as you see here, creativity, algorithmic thinking, cooperativity, and critical thinking may all be resources in the problem solving process. So problem solving may also be on a different level as a construct. So for the latent profile, we only use these 4 dimensions here. To identify a suitable number of latent profiles, there are several approaches available in the literature. Usually you rely on information criteria, but also the bootstrap likelihood ratio test. And there is also a weighting approach of Akogul and Irisoglu that weights information criteria in order to identify the optimal number of profiles from an empirical point of view. And it indicates 4 profiles. So 4 profiles may be in fact a good choice. 4 profiles may also be a reasonable maximum because we have 4 constructs in our latent profile analysis. However, it is important to note that you should not only rely on these empirical criteria, but the profiles should be meaningful from a conceptual point of view. I will show you this on the next slide. Here you see the result of the latent profile analysis. Here you see the neutral scale mean 4 because we relied on a 7-point scale of rating. And first, these profiles can really be separated. We have here the results of a MANOVA, and in fact, they are quite different, these 4 profiles, which is important. Second, it is always a problem if you carry out a latent profile analysis and these profiles only differ in terms of level. So you have a low level, students that are low in all 4 dimensions, then a medium group that are medium, and a high group, which is, as you can see here, not the case. I will explain the 4 profiles in detail to you afterwards. First, we have a profile with creative thinkers with a focus on collaboration. They are quite high in creative thinking. Cooperativity is also decent, and critical thinking. However, you can see that they self-report rather low algorithmic thinking. The second profile, here you can see students that self-assess themselves as low in all 4 dimensions. So low creative thinking, algorithmic thinking, cooperativity, and critical thinking. Also remarkable is profile 3. I colloquially refer to them as nerds. They are quite high in creative thinking. Algorithmic thinking is also decent, but you can see here very low cooperativity. So they don't like so much to collaborate. And here they are also rather high in critical thinking. The profile 4, this is maybe the best profile. These students self-report high values in all 4 dimensions: creative thinking, algorithmic thinking, cooperativity, and critical thinking. Criterion validity. As I said, we have also data on the computational thinking test. This is the performance test. And as it is Rush scaled, it is depicted on a logit scale. Well, as you can see here, we have profile 1 and 2. These are the low computational thinkings. These are the creative thinkers with low algorithmic thinking, and they score significantly lower than students from profile 3 and 4. So these are the nerds, and these are the great computational thinkers, very colloquially speaking. And as you can see here, the notches depict the 95% confidence interval. They are significantly higher in the computational thinking test results than profile 1 and 2. You can see here also 3 numbers. We formed proficiency levels based on the computational thinking test. And as you can see here, the students from profile 3 and 4, they are at the border from proficiency level 2 to 3. And students from profile 1 and 2, they are from the border of 1 to profile, to level 2. Well, we also checked whether there is a relationship with context variables, and what we found out that there is in fact a significant relationship with these profiles and gender. And we also carried out post hoc tests, and they indicated that females are overrepresented in the profile 1, so creative thinkers with not so high self-reported algorithmic thinking, and nerds are overrepresented by males. So what may be practical implications of special interests could be profile 1 and 3. Profile 1, algorithmic thinking, may be the link between computational thinking and computer science, but are other technical skills, and these technical skills may scare off students. So we may argue that it could be beneficial to use a visual program language such as Scratch to start with a project first with a clear case study, and then confront the students with code to also train their algorithmic thinking. It may also be beneficial to let them collaborate with students from the profile 4, the great computational thinking in all 4 dimensions. Profile 3, we have here the low cooperativity as a problem. It may indeed be a problem because cooperativity, collaboration is regarded as a 21st century skill. Again, Scratch may be promising because it relies on a social learning paradigm. Members in the community can share the project and learn from each other, and this may be a first step to enable these nerds to collaborate more, or find out about the benefits of collaboration. And for the teacher, it may be important to integrate them in teamwork. What are the limitations of this study? Well, the sample, as I presented to you, is narrow in scope. We have only students from German-speaking Switzerland. This is also a rather small sample, hence we had to apply a restrictive latent profile model. Also, a point is that the computational thinking scales are based on self-assessments. So the constructs may rather be self-efficacy estimates rather than performances. This is also a point to mention. To conclude, we identified 4 distinct profiles based on the computational thinking scales. Females are more often in the high creativity and low algorithmic thinking profiles, and males more often in the so-called nerd profile. Overall, I think about 2/3 of the students may need a specific support. We have here the profile 1, where the problem is the algorithmic thinking, profile 2, all 4 dimensions, and profile 3, where we have the problem with the low cooperativity. Thank you.
Okay, thank you very much for this very clear presentation of your study, including interesting implications for practitioners, for teaching. Yes, there are already the first questions coming in the chat. And if you want to ask questions, please raise your hand. Let's maybe start with the chat questions. Ivy Osman asks, how would you measure computational thinking through activities instead of self-assessments? Are there any materials on that? Have you looked into this, or did you use the self-evaluation because that's the best available measure? I guess that's the question.
Yes, this was a first step, and also an implication I wrote on a paper on this that it would be really important to have also activities or performance tests to evaluate creativity, critical thinking, always in terms of computational thinking. We relied on the computational thinking test and the computational thinking scales because they are internationally established instruments, as a whole, they may provide a quite good picture about computational thinking. However, I think a reasonable next step would be to get all in this creativity, critical thinking dimensions and develop performance tests or activity-based tests. Yes.
Okay, Eva has a question. Eva Marinos.
I think Sabrina was first.
Sorry, no, you were first,
I think we have time for both. Yeah. Let's just, sorry, it's hard for me to see. Thanks, Eva, but go ahead and then we ask Sabrina.
Thank you so much for this clear talk, as Karin already mentioned. I've got two questions. The first question has to do with your participants. So the original test by Korkmaz et al., that was validated, and they did all these reliability analyses with students. And your population seems to be a bit younger. And I was wondering, did you take that into account? Can you ask these self-assessment questions to a slightly younger population? That was my first question. And the second question is, well, they call it the computational thinking scales, but I would argue it's computational thinking and collaboration scales. I think one of the scales is measuring collaboration. And I think you also nicely show that when you do the criterion validation with the computational thinking test, that the two profiles that do well on algorithmic thinking and those, or not on collaboration necessarily, they are both high on the computational thinking test.
Yeah, thank you. I may come first to the first question. There is a 2019 paper of Korkmaz et al. Where they exactly used the computational thinking scales with students from the upper secondary level. And therefore, it may be, I think, a viable option to use this. You're right, they first, this paper I referred to, this 2017 paper, they used it with university students. And as I said, too, there were several problems that we faced with these instruments. So we carried out this thorough test validation. As I said, we had problems with discriminant validity. So to conclude, I think it is a good option to use the computational thinking scales, also at the upper secondary level. Question 2, with the collaboration, yes, as the criterion validity assessment shows, this cooperativity may in fact be a construct different from computational thinking because it is not really dedicated. If you also look at the sample items I provided and they are published in this paper, then they are not so computing related. And this is also what our findings indicate, that it may be in fact a construct that should not be included. in such an over computational thinking scale. Yeah.
Okay, Sabrina.
Yeah, my original question would have gone in the same direction, whether cooperation is actually something different than computational thinking, although surely a construct that's very important for many fields. But then let's ask about algorithmic thinking. So you had this group who was good on everything except for algorithmic thinking. But that group who couldn't cope with algorithmic thinking was nearly as bad as the one who couldn't cope with any of the four subfactors. What does that mean about algorithmic thinking to your mind?
Well, I would say algorithmic thinking is the key here. And also we also carried out a latent regression, and algorithmic thinking is, if you put all these 4 dimensions in, then algorithmic thinking is the only predictor for the computational thinking test score. So it basically depends on this variable. So you may argue that this is the link between the computational thinking scales and the computational thinking test. And as I said, you also in this box plot, you say it only depends on the algorithmic thinking. Cooperativity doesn't seem to play a role, which is also meaningful because in the computational thinking test, you don't have to collaborate. But again, as I said, it goes in the direction of the previous question. Should we include this cooperativity, or is it really a construct of a different nature? And I think this is a question worth to discuss.